All right, here we go. Unit 3, day 1, the product rule, where in this case, product means to multiply. So this is going to be how do we take derivatives of functions where things are being multiplied together. Now, product rule sounds like power rule, but it's different. So let's remind ourselves of a really key part of the power rule. It's that it only works when functions are in standard form, meaning anything that's left to be multiplied out needs to be multiplied out first. It is a common mistake, and so this is not correct. If you forget to do this and you try and just run through and say, oh, the derivative of 2x minus 3 is 2, the derivative of 3x plus 4 is 3, this derivative must be 6, that is incorrect because it is not in standard form yet. F of x is not in standard form. So to get it in standard form, we would multiply it all out. We would do all our distribution. So we'd have 6x squared plus 8x minus 9x minus 12. We'd have 6x squared minus x minus 12. And so now we can apply the power rule. 2 times 6 is 12. X to the 2 minus 1 is just 1. 1 times negative 1, we'd have minus 1, and x to the 0 is gone. So we have the derivative of f prime of x, is 12x minus 1. It's clearly not 6. Now there's another way to do this, and that's with the rule that we're going to learn today and that you need to commit to memory today. This is super, super important. This is called the product rule, where again, product means multiply. And so what the product rule tells us is if you have some function, h of x, and you can think of that function as some first component multiplied by some second component, the way you find the derivative is to take the derivative of the first term and multiply it by the second term left alone, and then adding that to the reverse, the first term left alone times the derivative of the second term. And so what you need to commit to memory today is basically just, okay, if two things are multiplying and I want to find their derivative, it's the derivative of the first times the second plus the first times the derivative of the second. And so let's repeat this process from the example problem. We should get the exact same thing. We should get 12x minus 1 if I go ahead and I'm going to say that 2x plus 3, that's our first term. 3x plus 4, that's our second term. And so what the product rule says is if we want to find the derivative of this function f of x, it says to take the derivative of the first part, so the derivative of 2x minus 3 is 2, times the second part untouched, so just times 3x plus 4. And to that we are going to add, now we're going to swap places. We're going to leave the first term alone, that's our f of x, 2x minus 3, times the derivative of our second term, the derivative of 3x plus 4, which is just 3. Now, if we were asked to simplify, we would multiply this all out. 6x plus 8 plus 6x minus 9. As you can see, we get the same thing. We get 12x minus 1. And so the product rule that you need to commit to memory, super, super important. Derivative of the first times the second plus the first times the derivative of the second. I'm going to show you one more example, and we're going to talk about when might you use the product rule versus when do you have to use the product rule. So one more example, and this is going to kind of call into question, I think, like what is the point of this whole thing, and then I'll resolve that answer. So let's say we have h of x is the square root of x times x squared minus 3x plus 2, and I want to show that I could do this using either the power rule or the product rule. So first things first, before I actually do anything else, I'm just going to rewrite this here. I know that h of x is equal to x to the 1/2 power times x squared minus 3x plus 2. What the power rule says is if I want to apply the power rule, I have to distribute and get this in standard polynomial form. So x to the 1/2 times x squared, which is 4 over 2. This would be x to the 5 over 2 when I add their exponents. X to the 1/2 times negative 3x would be minus 3, 1/2 plus 1, x to the 3 over 2. And finally, plus 2x to the 1/2. And so that's what h of x is. And so if I wanted to find the derivative, now I can simply apply the power rule. 5/2 comes out front. X to the 5/2 minus 1 is 3/2. 3/2 times negative 3 minus 9 over 2. X to the 1/2. 1/2 times 2 plus 1 x to the negative 1/2. So I didn't time myself there, but you could have timed me. Roughly, though, we're going to see what happens when we use the product rule and why we may sometimes prefer it and may not. So same idea here. Let's do h of x equals x to the 1/2 times x squared minus 3x plus 2. And I'm going to say, okay, I'm going to think of this as f of x times g of x. And so when I apply the product rule to find h prime of x, remember it's going to be f prime g, this is super shorthand here, plus, I guess I should write those in different colors. It's going to be f prime g plus f g prime plus f g prime. And so let's go ahead and do that. The derivative of the first term here is 1/2 x to the negative 1/2, and it is going to be multiplied by x squared minus 3x plus 2, and we are going to add to that the reverse. We're going to say that's now f, which is x to the 1/2, times the derivative of x squared minus 3x plus 2, which is 2x minus 3. Oh boy. Okay, so now we still have like a whole bunch of work still left to do to figure this out. So we could go ahead and we could now multiply all of these pieces out. We would have 1/2 x to the 3/2 minus 3x to the 1/2 plus x to the negative 1/2. And then we write this out. This is going to be x to the, 2x plus 2x to the 1/2 minus 3, to the 3/2 minus 3x to the 1/2. And so we go ahead and we combine our like terms here. Yep, here it comes. 5/2 x to the 3/2. And then we've got, so we've done those two. Then we've got negative 3 x to the 1/2 and negative 3x to the 1/2. And so, sorry, this should be 3 over 2. I missed that when I did this one. So negative 3 over 2, negative 3, this would become minus 9 over 2x to the 1/2. Plus x to the negative 1/2. Okay, geez. So that was a real pain in the butt, right? And so I did that, and I wanted you to kind of suffer through that once just to let you know, right? You don't always have to use the product rule. If you can, key point here, right? Like I messed that up a million times here. The key point here, if there is a way to rewrite as a polynomial function and just do the power rule, it's easier and you're less likely to make mistakes. So if you can simplify, do it. If you can simplify and use the power rule, do it. So why do we need, this should say here, why do we need the product rule? Why do we need it if it's usually easier to rewrite? And the answer is you can't always rewrite. So here's our last example that we'll end on today. If you had x squared sine of x, there is no rewriting that as a polynomial function because it's not a polynomial function. It's a trigonometric function. We cannot simplify this any further. We have to use the product rule. So if I have g prime of x, I'm going to declare x squared to be my f of x, sine of x to be my g of x. So the derivative here would be 2x, derivative of sine is cosine, 2x cosine of x plus x squared. Oh, I did it wrong. 2x sine of x, because remember, it's f times g prime. No, sorry, f prime times g plus f times g prime. I need to write it out every time, or else sometimes it's easy to make a mistake here. F, which would be x squared, g prime, the derivative of sine is cosine of x. And so your final derivative here would be 2x sine of x plus x squared cosine of x. Derivative of x squared is 2x, and then you just multiply by sine of x, plus x squared times the derivative of sine, which is cosine. That's your product rule.